Time to spend a little time with SLA, and not the one that kidnapped Patty Hearst back in the day. And I threw that in for one reason. First off, I never mind telling anybody how old I am because I've never felt better and I'm happy with life as I can be. I'm 52 years old. I'm thrilled with my life and I'm feeling great. So yes, it can be done. But it is impossible to say SLA to someone of my age, maybe a little younger, because I was 10 when that happened, that you don't immediately see Patty Hearst and her little machine gun, which would be big if she pointed it at you, a little beret and in front of that flag. You just can't help it. But we're not talking about that SLA anymore. So we're talking about this one. And during your frame relay studies in your CCNA days, you were introduced to a topic that's similar to an SLA. It was the committed information rate. And the CIR is basically a guarantee that's given to us, the customer, by the frame relay service provider. And the provider says, for X dollars, we guarantee you'll get Y amount of bandwidth. You might get more, but we guarantee you won't get less. And given that guarantee of minimum performance, you and I, as the customers, the network admins, we can plan the WAN appropriately. Now, the SLA is based on the concept of minimum guaranteed performance, but this agreement is between different parties. It can be a lot like the CIR, where the service provider guarantees a certain level of overall network uptime and performance, or it can be between the internal clients of a company and the network team at that same company. Now, the SLA can involve just about any quality measurable value in your network, including voice, available bandwidth, levels of jitter, speaking of voice, DNS lookup time, trouble notification, resolution time. These can all be tracked by SLA. And I'm just giving you a sneak peek here on the board of some of the available tests because we're actually going to run one simpler test here in the lab. I want you to see all the show commands and we'll do a live test on that. And as you can see, we've got DHCP, DNS, FTP, HTTP, ICMP echo. We've got a path discovered for ICMP echo and jitter, a TCP connect operation, UDP echo, UDP jitter, and finally video operation. All of these tests, though, work fundamentally the same. An SLA is going to have a source and a responder. And to kick off the festivities, the source is going to send control packets to the responder via UDP port 1967 in an attempt to create a control connection, kind of like the one in FTP, where they talk to each other before they actually start doing anything and they have this underlying connection. That's really what this is. This connection is not the actual test itself. It's an agreement on the rules of communication. And in this case, the rules that the responder is getting, that includes the port number to be listened to during the test and the time limit on that listening. Now, should the responder be kind enough to agree with these rules, it'll send a message back to the source indicating that, and then the responder will start listening to the indicated port. If the responder doesn't agree, it'll send a message back indicating that decision, and our story ends right then and there. Now, we now go from controlling to probing, because with that control connection in place, the source will start sending test packets to the responder. And the source wants to see, first off, if the packets are echoed back and how long the overall process is going to take or takes. Now, the responder is going to add timestamps to those packets, both as they're accepted and as they're returned. And this gives the sender a better idea of the overall time the responder took to process the packets, as well as the overall round trip time. And you can see again another situation where network time protocol really comes into play. You've got to have synced time here, because if one of the devices involved is way off in time, whatever value you get back from SLA is really just going to be invalid. You can't use it. Now, we're going to go ahead and start an SLA lab right now, and MLS 1 is going to be the source, and router 3 is going to be our responder. So let's go ahead and bring the live equipment up. Line that baby up, and let's go ahead and get started. We've got IP SLA, and quite a few options here. I'm just going to warn you, we're going to have screens of options. We don't need to know all of them or use all of them yet. Right now, what we're going to use is an entry number. And I'm going to use 5, and that's going to be it. And you'll notice I got dropped down into SLA config mode. And the test we're going to run is an ICMP echo test. Very simple test. And then there's the destination IP address or host name, and broadcast is disallowed. So you can't just broadcast your test pings all over the place. 10.113. And we have the option to change the source interface of the source IP address. We're not going to do either one of those. So now we are all the way down into SLA, ICMP, Echo config mode. And let's look at our values here. One in particular I want to draw your attention to, and that's frequency. Frequency of an operation. I'm going to set this one to 60 seconds just to remind you that that is the default. So we'll put that in, and of course, what are we going to do? See iOS help to see what the time unit is here, and it is seconds. So actually, I'll go with 30, and we'll cut the default in half. So we've got a frequency of 30, and that's all we're going to set there. So we've actually created the test. We've defined which test we're going to do, which is ICMP Echo. We've defined who we're doing the test to, if you will, 10.113, and how often that test is going to be run. Now, let's step back a bit. What do we need to do with a test then? We need to schedule when it's going to happen. And we do that with IP SLA schedule. And there's your entry number. I'm going to stick with 5. And we've got age out, life, recurring, and start time. Start time seems to me to be very important, when to start the entry. And then you can set a certain time, or you can start it a certain amount of time from now. If you say, oh, okay, I'm going off to lunch and I want you to start this in 75 minutes, then you could put that in. But what I'm going to do is do now. And that's it. So if I started the test now, let's see if it's actually started. And let's run show IP SLA. We've got a couple we can use here. And let's start with config. And this is going to show you what you just filled out and a whole lot more, I freely admit. Again, that's show IP SLA config. And entry number from the top, entry number is 5. And here's the target address. We didn't specify a source address, so it's going to be all zeros for that. And operation frequency, 30 seconds, not considered if randomly scheduled. Next scheduled start time, well, by golly, you already missed that because we are doing it now. And let's see, there's a life seconds of 3600, entry, recurring, false. You know, it's telling you whether you set it to recur or not. And then that is it. So we've got some history statistics down here. Not really concerned about those right now. And how about statistics? And you can see it's already run 3 times while we were gone. You also see what? You see that we have an ancient time. This is a good thing to check when you're running your statistics. We're actually fine here because I actually took both devices and did a write erase between sessions, reloaded it, so both of them have this. But this is another point in SLA, show IP SLA stat, and it's going to show you when you started it, or the latest operation start time. And if you see a year that's way gone, then you might want to change your clock. So we'll definitely take care of that. But it also shows you how many successes you've had. So far we've had 3. And the number of failures, so far we've had 0. And how much longer this operation has to live. It also shows us our round trip time. Right now the latest RTT is 1 millisecond. And since then, you can see it's run another test since then, since I was talking. And hopefully the successes will continue to increment and the failures will stop at 0. So let's say now that I've got this test running. I was like, oh, I meant to change it to, I want to set the default back to 60 seconds. Or I want to change any other value. So I would just go conft and then IP SLA 5. And you get this message. Entry already running and cannot be modified. So the only thing you can do is actually delete this entire operation and start it over with the value that you wanted, and then check to see if the probe has finished exiting. So isn't that something? So if you've got an SLA test running, you either have to get rid of it or just wait until it's over and then run another one. So it just depends on what you wanted to change and how badly you wanted to change it. Let's do a show IP SLA stat again. And you'll notice we're up to 7 successes now, and the operation time to live continues to go down. So it's pretty much what we expected. Now, there's one thing. Did you notice anything particularly odd about this entire lab so far? Anything unusual? How many devices do we have involved in this? We have 2. How many have we configured? 1. Well, the thing is, let me find a little bit of info here for you that I wanted to show you. That's about the SLA test. Now, for an ICMP ping echo test, I didn't need to put anything on the responder because I know the responder could handle pinging. We've been pinging router 3 throughout our videos. For some of those other tests, though, you might want to run a command called IPSLA responder. And all you're doing, according to iOS help, is enable IPSLA's responder. For some of those other tests that are more complex, you may well need this. It doesn't hurt to put it on there anyway, to be honest. I could put IPSLA responder, and it's not right now, it's not like it's going to hurt anything. But for a simple ping test, I really didn't need it. So that is a fundamental SLA test. And also you saw when you can't delete one. Changed a couple of values, ran a couple of show commands. Definitely enough to get you started if you're interested in learning more about SLA for your future work. So that concludes this lab. I will see you on the very next video.